Hi everyone, welcome to my video. Today we're going to work on an interesting question and we will try to generalize it for any real number a. So the question is, we have square root of 90 plus square root of 90 plus square root of 90 plus square root of 90. This continues indefinitely, and then we want to subtract from it another expression that is 90 minus square root of 90 minus square root of 90 minus square root of 90 minus and so on, right? And we want to know what is this subtraction equal to. Now, if you want to pause the video and try it yourself and see that if you could come up with an interesting method to solve this inspiring question, right? So okay, so if you let the first expression to be x and the second expression to be y, that means we have x is equal to root 90 plus root 90 plus and so on. If we square both sides, that means we're going to have x squared is equal to the whole thing squared on the right hand side, and that square will cancel this first square root sign, which will set this 90 here free. So we will have x squared is equal to 90 plus square root of 90 plus square root of 90 plus and so on. In other words, if you look at this expression here, it's the same as that. We are manipulating the bizarre nature of infinity. That means this must equal to x as well. So the quadratic boils down to 90 plus x. So that implies x squared minus x minus 90 is 0. Factorizing it, we get x minus 10x plus 9 is 0. So x must be 10. Right. I'm going to ignore x is equal to minus 9 because we are clearly looking at a positive expression for x. Now, if you did the same thing for y, you will get another quadratic, and that quadratic will be y squared is equal to 90 minus y this time. Right. Just, if you're unsure, just try it and justify it to yourself. And this quadratic will be, we have y squared plus y minus 90 is 0. Factorizing, we'll have y into y, and that would be y plus 10y minus 9. That means y is equal to 9, ignoring the negative solution. And what did we want to work out here? We're interested in x minus y, the first expression, take away the second expression. So if x is 10, as in here, and y is 9, that means x minus y is equal to 10 minus 9, which is equal to 0. I apologize, of course. It's not equal to 0, which is equal to 1. Right? Now, it's quite remarkable, actually. X minus y is equal to 1. That's it's quite complicated looking expression. The difference boils down to 1. Right. Okay, so what is more interesting is, what if we did this operation for a general number a, so for an arbitrary number a. In other words, what if we're interested in this? So a plus root and a plus continues indefinitely. We want to subtract from it a minus square root of a minus square root of a minus and so on. What is that equal to? Well, so looking at the above quadratic equations, we have for x, we had x squared is equal to 90 plus x. So we will have x squared is equal to a plus x. And here we will have y. We had y squared is equal to 90 minus y. We'll have y squared is equal to a minus y. So in other words, now if we do, if we rearrange it, we have x squared minus x minus a is equal to 0. We will have y squared plus y minus a is equal to 0. If we subtract, we will have x squared minus x minus y squared minus y is equal to 0. A's just cancel. That means we have x squared minus y squared is equal to x plus y. If we remove x and y on the other side, right? Using difference of squares, we have x minus y into x plus y is equal to x plus y. Now, assuming x plus y is not 0, so we divide both sides by x plus y. That means we will get 1 on the right hand side, and this will cancel, so we have x minus y is equal to 1. And notice we achieved this considering an arbitrary number a. Okay, so, well, I'm not sure if this general proof holds for any number. I consider a to be a real number. So if you can find an exception or an interesting number that wouldn't obey that this derivation, so this proof, so please let me know, and thank you for joining my video, and I look forward to seeing you again. Thank you.